Hello everyone, in this video we're going to be doing the free responses on page 19. So this first one is 2010 number 2, which anytime it says 1 or 2 it's a calculator question, so you will definitely need a calculator. And so they give you a table for E of T, and it says a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box from 0 to 8, and the number of entries in the box after T hours, afternoon, is modeled by a differentiable function E. Values of E of T is the units as hundreds of entries, and various times T's are shown above. So then it says, use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at 6. So this is the same thing, we're approximating f prime of 6, the rate, because this is hundreds of entries per hour. So you find where 6 falls, and you're going to use these 2 points, and you're going to get the average rate. So f prime of 6 is going to equal the average rate of change from 7, f of b minus f of a, which is 5, over b minus a. So we're going to do it on another sheet of paper. This is 2010 number 2 for A. I'm going to rewrite that down. I should have wrote it down on here. So it's going to be approximately this average rate of change, which is f of 7 is 21 minus f of 5 is 13. And then we have 21 minus 13, which is 8, over 7 minus 5, which is 2. Which we could simplify that to be 4 if we wanted, and then let's put our units, which it told you the units you wanted, right? Hundreds of entries per hour. And, oops, what am I don't know how I'm spelling entries. Entries, make that 1 R per hour. So for B, it says use a trapezoidal sum with 4 subintervals given by the table to approximate. Now notice, this is 1 over 8 times this integral from 0 to 8. So a sum, whether it's left, right, midpoint, or trapezoidal, it approximates just the integral, the area. And so whatever you get for this sum, you can't forget to multiply by that 1/8 value. And then we're going to explain what that is. So hopefully when you see this, it rings a bell, because this 8 is 8 minus 0. That's how they got it. So it's 1 over b minus a times the integral. So that's average value formula. But let's first estimate it. So trapezoidal sum with 4 subintervals that's given by the table. So they're not going to necessarily be equal width, but if we notice, this is going to be 1, 2, 3, 4. So how do you do area of a trapezoid? It's 1/2 times, normally you say height, but in this case our height is actually going to be our width times base 1 plus base 2, which those bases are going to be y value plus y value. It's supposed to say value. Okay, so for the first one, now keep in mind, I'm going to go ahead and write so I don't forget. I still have this 1/8. That is not my trapezoidal sum. That's just from what they gave you. Now in parentheses, I'm going to approximate this integral using trapezoidal sum. So my first trapezoid is going to be 1/2 times the width. So what is this width? It goes from 0 to 2. So times 2. Times b1 plus b2, so it's the y values, 0 plus 4. And then you're going to do plus the next trapezoid will be 1/2 times its width, which the next one goes from 2 to 5, so the width is 3, plus its y values, 13 and 4. So I'll put 4 plus 13. Plus, now you gotta do the next one, 1/2 times, I'm going to stop going back to the table because I feel like it's getting confusing. But the next width goes from 5 to 7, which would be 2 times its y values is its basis, so 13 and 21. So you should be using your y values more than once, except for the end y values. And we have one more, plus 1/2 times its width from 7 to 8 is 1, times its y values 21 and 23. Okay, so we got to evaluate this. So you can pause the video and try to do this on your own, or whatever you need to do. But I'm going to keep this. You know what I'm going to do is every single trapezoid, you could think of it like its own term, and every single one had a 1/2. So I'm going to pull out a 1/2 and multiply it by this 1/8 that I already have in the front. So I'll multiply it in a second. I just want to show that I pulled out the 1/2. So now it's just 2. And I'm going to go ahead and add my bases. 0 plus 4 is 4. I pulled out every single 1/2. And then I have 3 times 4 plus 13 is 17. Plus, I already pulled out this 1/2, so 2 times 13 plus 21, which is 34. Plus, I pulled out this 1/2, so it's 1 times 21 plus 23, which would be 44. That's a little easier. So, now 1/2 times 1/8 would be 1/16. Times 8 plus 17 times 3 is 51. 34 times 2 would be 68, right? Plus 44. Now we can add those up. So 8 plus 51 would be 59, plus 68 plus 44. Gotta go do some old school math, which would be what? 17, 18, 19, 20, 21. This would be 10, 7, 171, I believe. Let me just make sure before I keep doing this problem wrong. I should just go with it because this is taking too long, but oh well. I would hate to do a video and me make a stupid mistake. Yes, so 1/16 times 171, and you could just leave it like that, 171/16. So what is that? Let's go back to what we were doing, because sometimes you get lost in just the math. That is the approximate value of this 1/8. So let me go ahead and write down what I was doing. Is the 1/8 times the integral from 0 to 8 of e of t dt is approximately 171/16. Why is it approximate? Because we used a Riemann sum to approximate this integral. So if we think about this, what are our units? So you have to identify this format, that this is average value. So let's go ahead and just put it in a sentence. Now that we determined that's average value because it's 1/b minus a, because 8 minus 0 is 8, times the integral from a to b of some function is going to give you the average value of that function for the interval a to b. So let's put that in a sentence. The average value, I could write value, of e of t is approximately 171/16. Now what are your units? It's the average value of e of t. So what is e of t? Hundreds of entries. So the units, remember, don't change when you do average value. So hundreds of entries is approximately 171/16 hundreds of entries for the interval 0 to 8. Or you could say for the first 8 hours. Okay, that is part B. Now part C says at 8 p.m. volunteers begin to process the entries. So at the end of at 8 p.m. Right, that's where this leaves off. They process the entries at a rate modeled at the function P, hundreds of entries per hour. Oh, you know what? I just did this all by hand, and this is a calculator question. So could you have done this all in the calculator? Yes. My bad. I'm so used to things not being calculator and calculus. Anyways, so they're processing them at a rate. Okay, this is a rate function. I'm going to use a different color. I'm trying to use a different color for each section. You notice the units. It's hundreds of entries per hour. That per is a rate. And so according to the model, how many entries have not yet been processed by midnight when T is 12? So you have to think about this with how many are you starting with? So it's starting at 8. So what is your initial condition at 8? How many entries do they have? Well, you got to use the end of this table, right? Your initial condition is E of 8 equals 23, which is technically hundreds, right? Trying to fix that. So that's your initial condition, and then they're processing them at this rate. So how do we know how many they've processed? Is you integrate your rate, right? So we're going to take, where is it? 20, how much, our initial condition. Now let's think, if we're processing them, then it's kind of like an out rate. It's how many they've taken away and have actually processed. So you start with this amount of entries, and then we're going to subtract how many they've processed. So to get how many they've processed, you got to integrate your rate. And they start at 8, and we're talking about they end at 12 of our function P of T. Okay, so then if we do that in the calculator, look, that's me checking my math. 23 minus, then you 2 from 8 to 8 to 12. And then we're going to type in our P of T, so I'm going to say x cubed minus 30 x squared plus 298x minus 976 dx. 6.999. So what does that mean? Is how many entries have not yet been processed. That's how many you have left. So this is what you started with, and then this is how much they've processed, and that would be what you're left with. So they have 6.99 hundreds of entries left to process. Okay, next one says according to the model for part C, at which time were the entries being processed most quickly? So, what is that asking? It's saying for this interval, when was it being processed most quickly? So, you're asking about when did this P of T get its absolute maximum, right? That's whenever they're being processed most quickly, that's when P of T has an absolute maximum for the interval 8 to 12. So how do we find an absolute maximum? You find your critical number, and then you test your critical number and your endpoints into that function that you're talking about. So pay attention, we're talking about when is P of T have an absolute, when they're being processed most quickly. So its critical numbers is when P prime of T equals 0. So we're going to first find when p prime of t equals 0. So what's the best way to do this one is I would go ahead and get what is p prime. It's pretty easy, and set it equal to 0. So p prime of t would be 3t squared minus 60t plus 298. We want to know when that equals 0. So I would graph this function and look for x-intercepts. Get x-intercepts to know when it equals 0, and you want them in the interval from 8 to 12. So let's see. I didn't already do this one, so we'll do it together. If you have Desmos on your computer, you can use that as well. Wait, oh yeah, this plus, okay. So I'm going to have to scoot over my window. So I'm going to go to Menu, Window Zoom, Window Settings. I'm going to make my X-min, because my interval goes from 8 to 12. I think I go by 1 just because I want to. I'm not going to change my Y just yet because I'm not sure what it should be at. And we can see we have 2 x-intercepts. So I'm going to get those. Menu, Analyze Graph, 0, highlight them, 9.18. And the other one is 10.8. So those are your critical numbers. So to know an absolute max, you're going to take your critical numbers, and you're going to take your endpoints, which our interval goes from 8 and 12, and you're going to plug them into the original. So our original, I shouldn't have even wrote f of x. What are we finding the absolute max of? P of t. So our original is P of t. And you just use your calculator and you're going to plug them into this cubic polynomial. So Control-I, add calculator. Let's see how fast we can do this. So 9.18 cubed minus 30 times 9.18 squared plus 298 times 9.18 minus 976. And that is 5.088. Okay, so the next one I'm going to do is highlight this and just change my 9.18s to 10.8. Oops. Double check it. Looks right. 2.916 or 912. Now I'm going to change my 10.8s to 8. Which is nice because you can just delete the 0.10 part, keep the 8. And I got 0, which makes sense because they didn't start processing until right after 8. And then 12. So change all my 8s to 12s. Oops. And that is 8. So we want to know, what is this? This is the rate, right? Because P of t is a rate that they were processing. At 9.18, they were processing at a rate of 5.088. At t equals 8, they were processing at a rate of 0. So we want to know, when were they being processed most quickly? Well, the highest is this one. So, and it asks for at what time were they being processed most quickly. So that's asking for the x value. At t equals 12, they were being processed most quickly. And if you had all that written down, that would be enough justification. Okay, so I'm going to do the last free response in the next video.